Well, gentlemen, this is a new one to me. Never seen one of these before. This is the Palomar 3500Z or 350Z. And this guy sent me this amp a long time ago, like 18 months ago, to look at. And he's called me quite a few times wanting to know when I was going to get around to looking at it. And I kept telling him, dude, when your turn comes, you're close. I mean, it takes forever. Remember, guys, one-man band. A million of you, one of me. And so he kept calling me, yeah, my Palomar, my 350Z, and I kept thinking he was saying 3500Z. I'm like, Palomar never made anything with 3500Zs in it. This thing is actually in really, really, really good shape. This meter here is just chilling in the wind here. We're going to fix that. I just kind of got it propped back up in here in this little spot, which the adhesive that was holding this meter in place has fucked off. I guess the best way to put it. It looks like somebody's tried to super glue it. It's okay, we got better glues nowadays, so we're going to fix that. But I just want to get the intro card here kind of shot. This is the Palomar 350Z. Not nearly as common as the Palomar 300A or the Palomar 300 or the 123 but it's the exact same principles. This is 2 driving 4, which is pretty much the same thing as a the Palomar 300A. But what we're going to do here first, before we get too carried away, is we're going to find out what we're working with. I got the Invenerable 747 tube tester out, and we're going to test all 6 of the tubes that are inside of this thing. And then before we go any further, we'll pull the bottom off, and I want to look at the power supply and the rectifier circuit and all that stuff. And then we'll bring it up real slow on a variac, and let's see if we can get this old girl running for him. But like I said, internally, I'm used to these being all rusty and needing a tetanus shot once you look at them. This thing is not that bad. I mean, it's really not. There's like a passive coupler on the inside of this thing. We'll cover all of that here in a minute. This is going to be fun. Gentlemen, the Palomar 350Z. It's a 6LF6. That means socket number 21. We reset all of these. We set the sensitivity to about 48, and we put the heater on 6. Let it sit for a second. 60% or so. They've got 110 written on the tube. Here, let's zoom on in here so you guys can see what the hell I'm doing. Test 2, nothing of course. Test 1, about 70%. Nothing here, no shorts. Okay, well, I've got 110 written right here on the tube. Let's reset the record. And we'll put on here 70. Okay. That choke's seen better days. Still, this thing is in great shape. 70% is enough to get it up there and get it to do something. They've got 56 okay, and then they got 56 okay written up here in green Sharpie, and then they got 110 over here. So we'll see what it says. I love this tube tester. When I first saw one of these when I was a kid, I mean, we're talking my teens, like 16 years old, I was like, man, that's kind of nice. How much that cost? Oh, 250 bucks. Remember, 1990s dollars. Take my headset off, my phone's ringing. 1990s dollars, right? So that was a lot of money to me back in those days. Let's see, test 2. We're in the danger zone, man. Let's let that warm up a little bit more. This is the problem with testing sweep tubes. Patience. 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 See? Now we're up at 70. And my fingers are old and frail and weak. I can't sit here and hold this button forever. We're going to call that 70 as well. So when I got older in life and I decided that I was going to start pursuing this as a thing, right? 70. I went shopping. Basically, I went and I looked at them on eBay and I went, I ain't paying that much money for one. So I hit up my friend, Mr. Zane at Big Rig Radio, and I put him to looking. And where Zane lives, he's got like 15 Hamfests a year. Up here on the top of the tube, they've got 5,000 written. And that's it. So we'll see what it does. And there's such a large density of people, and it's snowbird country, man. That's where everybody goes to retire. That, and there's I would argue there's probably 3 little pockets of the most technologically advanced. I wouldn't say technologically advanced. I'd say, how would I put this? Is you go across the country, you're going to have places like Huntsville, Alabama, and, you know, around the Cape down in Florida, and a couple places in Texas, and then in the valley in California, where you've got huge, large populace of people, huge infrastructure, big production, and also you've got big space programs. And a lot of guys that have messed with radio for a living for a long time, right? Well, that's a good tube at 80. 80%. Solid. Solid 80. We're going to call it 80. So down there in Phoenix, I did not realize that there was so many aerospace companies in and around Phoenix, and there was such a high density of radio communication things. Like, you know, he come out here for the first time, and we're running around, and I'm showing him our little electronic recycler joint, which I'm grateful that we have that. Just that. I mean, it's better than nothing, where most of the country has nothing. And he's laughing at me the entire time. So it says 110 on it again. Up at the top it says 5,600, whatever that means. He's laughing at me the entire time. He's like, oh man, you got to come to Phoenix. And I kept thinking, it can't be that much better than here. It really can't. Oh, dude. I passed through there on my way back from Texas one time, here a couple months ago. We spent 2 days going to just electronic recyclers, where the aerospace industry offloads all their equipment. We're talking warehouses bigger than Costco, full of minty mint vintage electronics that I went several $1,000s in debt while I was there. I couldn't help myself, needless to say. But Zane got this for me on a steal. Back to the original topic. He got this for me on a pretty good steal at a Hamfest. The hinge was busted off on it, and the latches don't work no more. I had to go through and completely recap it and just touch up some solder joints and stuff, but You know, B&K, all their stuff's out there on the internet, and I downloaded the alignment manual and made sure everything tested within spec, and it did. And I mean, is it the belongs in the B&K museum? We're going to call that 75%. No. Does it suit me and the way I am as a human being and the way I'm going to use stuff? You betcha. Makes me happy. I know for a fact there's a guy that lives down the street that's got one twice as nice as this. That does not make him any different than me, and it does not make his read any better than mine. I got this for a deal, like a screaming deal. Only for like 2 months later, Zane picked himself up one for his shop, and it's mint. This one says 5,000 on it, nothing else. I think that's great. It can slowly die the next death in the other hands of the second generation at his shop. Because remember, none of this stuff is new to us. None of this is new. Everything that we get to buy in this vintage here is all used. Which has kind of got me worried, because if the filtering caps in this son of a gun over here are messed up, oh man, we're going to have to order more parts off the inner boob that are used. Maybe we can find some good old stock, vintage, non-used, on-shelf, new old stock kind of thing, but 60, 70%. Let's let it warm up a little bit more. We got one more to go, guys. One more to go. I had a conversation this morning with a guy. Well, I didn't really have a conversation. I had to add my 2 cents. I was listening to this gentleman describe to a set of his peers about tuning a 102-inch whip. We're going to call this 70%. And this guy is supposedly a heavy-duty antenna expert. It made me cringe listening to what he had to say. He didn't believe in springs. He doesn't believe in... You got to have a spring on your 102-inch whip, or you got to have a whip extender. Because a 102-inch whip is not naturally resonant for 11 meters. Or 10, actually, without that spring. That spring counts as an electrical length. And he was not having it. But it's all good. It's all good. It's all good. I just say read a book. It's in a book. Take a look. It's Reading Rainbow. Reading Rainbow. Well, last tube. I want to see this thing run. Because to me, this is like a 300A without the external power supply. And one extra tube over the 300. At least that's what it looks like on the outside. I'm standing here looking at this. So it looks like to me on the outside. I'm just grateful this thing is in such good condition, because when I was looking at it initially, I thought it was all effed off because this meter was pushed in. Like I said, we'll fix that. Have faith. Okay, let's see how we're doing here. Nothing. All the final tubes are at 70 or 80%. Yeah, we'll call it 70%. Okay. Needless to say, no shorted bad tubes. 70. All right. Let's get the 747 put away. Let's start playing over here. As we let that time-activated 10,000 PSI epoxy set up, Don't use super glue on meters, you guys. Please, Senelic just leaves white residue on everything. Go to your local hobby shop. Hell, go to your Ace. Go to your Home Depot and get 2-part 5-minute epoxy. Do a 1-to-1 ratio on it. Put down tape where you don't have epoxy get on stuff. Like I put down a layer of masking tape across the front of this thing, a layer of masking tape across the back, and I just laid a single bead of 5-minute epoxy across back there, and that'll more than adequately hold that meter in forever. I wanted to get onto this right away because that meter is like, you can't replace it. It just, that's, man, that meter gets broken, forget it. Game over. Meter broken forever. Okay? It's just, there's no such thing as a replacement part for that. There might be some guy out there that contacts me after watching this YouTube video and says, hey man, I got a whole drawer full of them. I don't know who he is. And I don't know anybody that would know who he is. So if you happen to have the very rare blue 3500Z or 350Z Palomar meters out there and you got a whole drawer full of them, you want to part with 2 of them for parts for me, I might be interested in talking to you. This amplifier looks really good. I mean, like, really good. The outside of it's in great condition. The bottom side of it's in beautiful condition. This knob here on the back is a 4-position knob. It says input, 1 watt through 10. So 1 through 10 watt input. And that's 2 stages. Now the output says 11 through 100 watt input. But it's in 2 stages. Now on the bottom side of this, I'll show you there's 2 different coax connectors hooked up to the output. Now in the 300A, when you would hit the high and low switch on the front, all that would do is kick out your driver tubes. So then you're just running right on your finals. Okay. And that's where they nerfed it, is they had a variable air capacitor, a little Arco capacitor that was on the input of the 4-pill or the 4-tube section, the final section. And they had that muted way down. So, you know, everybody and their brother drilled a little hole on the bottom of the cabinet. It usually was, we'll say this is the bottom of the Palomar 300A. There'd be a hole like right here. You take a screwdriver and get up there and adjust that. So I just took a quick look at the switch, a real quick look at the switch, and I didn't quite track it all down. We're going to look at it. This is very simple. We'll take a look at it when we get on the bottom side of things here. Of course, we don't have any high voltage hooked up to any anode tips, because once again, I haven't looked at the circuit that closely yet. Give me a minute. To see if it's switched high voltage or constant high voltage on the top of the tubes once we power it up. If it's switched, then I'll attach the top of the anodes, because I want to do the air bottle test. These are glass vacuum envelopes, just like 3500Zs. Treat them accordingly. Turn them on, watch them for a couple minutes. Make sure that the tubes don't fill up with white smoke from the filaments turning into powdered dust on the inside from them being inside of an air bottle instead of a vacuum. I think this is really neat. This is a coupled inductor coil here. This is ground. This is the hot lead on the coax that takes off and goes down. I'm sure it goes to the relay or a switch. This long inductor coil goes off and goes to our taps on our input or in our output section, which we'll cover all that here in a minute. Believe me when I tell you I've taken the 300A and I've operated it outside of the 11 meter band and it doesn't work so hot. Very dirty. Not the greatest thing in the world. So just keep that in mind. I want to give this glue a hot minute to do its thing. And then we'll start flip-flopping this all over and we'll take a look at the whole thing. Here's the bottom side, you guys. Let's go ahead and zoom in here. We're going to document all of this as best we can. We're just going to hover here for a couple minutes as I talk. This is our 2-pill driver section. And you know, if you're needing to look at this video for reference on this rare unicorn, this is what it looks like before it's all butchered up. This is our low drive, high drive switch. We have two separate coaxes hooked up here. I mean, you want to talk about cutting it close. Look at this second one here, right above my pinky nail. This is also our high-low switch here. So it's obviously dropping this section out. And with both these wires hooked up, you can tell how this is wired. This comes directly from the switch in the back. And this runs over to attenuation of some kind. So we'll mosey on up here. There's really nothing over here to look at. Our actual caps. These are axial lead 450 volt filtering caps for the high voltage section. These have a tendency to leak and dry out. This is the number one problem with Palomars, are these two caps. They will leak and they'll have stuff dribble out of these over the years and they'll be white. If you ever open up a Palomar 300, 300A, 123, any of those, and you look at these caps and there's a little bit of white jizz, I mean, it looks literally like dry boy juice. I'm not kidding you. It's a white crusty kind of schmew that builds up over here on these posts or on the backside back here. Don't even try and power it up. Those caps are bad. They've lost their magic jizz. Throw them away. Get brand new ones, put them in their place. Don't even try to power it up. Just don't. And the same thing here, by the way, with this cap. Man, this thing looks straight. I want to power it up. Let me get my Variac. Let's power this thing up. I have really good confidence this is going to work. What we're using is sewing machine oil. We're just putting a couple drops. There's not a lot of solids in sewing machine oil. It's oil that is specifically designed not to attract dust. Still feels a little tight to me. There's little tiny felt pads that sit on the bushings on this fan. That's still a little too tight. There's little tiny felt pads that maintain the lubricant to the bushings, and sometimes those felt pads will dry out a little bit. So we go right down through this oiling hole. There it is. Aww. There we go. It does not take much. That'll work. Okay. Just try to put a little bit of lubricant on them. Do not use WD-40. Do not use CLP brake free. It'll attract dust and cause more problems than it's worth. Okay, so over here we got the Variac set up. Amplifier is in the on position. We have it in low, we have it on standby, it's in AM mode, and the preamp is in the off position. So let's go ahead and we'll plug this in. Turn the Variac on. And let's slowly start turning the knob. Yeah, it's looking good. The fan's going to turn. As I'm turning the knob over here, you guys, what I'm feeling for is resistance. You'll feel it. It gets crunchy and it doesn't want to go. And that's telling you that there's something wrong and to stop. Back off, reevaluate, let's look at things. So both the lamps are working, that's good. Tubes are coming up, we're at 75 volts. 85 volts, 90, 100, 105, 110 volts. We'll just sit here and we're going to watch this thing for a few minutes. Tubes all look good. We know we had them on the tester. Still want to do the vacuum test. Okay, let's do a hard shut off on that. Variac down. Let's grab our high voltage probe. Although that this is only 600 volts in the right situation, this will kill you. Kill you dead. So always treat it as if it's like a jabillion. It will hurt, and it'll hurt a lot. Most likely it won't kill you, but it can. Nothing here. No high voltage here. No high voltage here. Nothing here. Okay. Let's go ahead and let's set up our anode caps, and we'll try this again. Boy, this thing did not want to play well with others. I'm here to tell you what. Had to make some adjustments to some of the things on the bottom, like I had to adjust our bias voltage a little bit. And there's a the keying circuit on this thing is variable, and it did not want to stay latched, so I had to go and adjust that a little bit. I'll show you that here in a minute. This high-low switch, all this does is when you put it in low, it pulls down your plate voltage by about 200 volts, and you can't see it on the watt meter. The knob in the back, all that does is it drops the driver section completely out. So you'd use it, you know, you could use like a 101 or whatever to drive into this, but on the 4-tube section, there's no variable for the tune on the input on the 4-tube section at all. So when you drop the driver tube out, the input estimator goes way up. So it's just this is the last iteration, I think, of this style of amplifier, and it's just not. Yeah. Anyhow, we got it in operate. We've got it in high, and you got to remember we're running on 60 and 70% tubes. Let's keep that in mind. Okay. So let's go over here real quick. Now here we've got a 1,000 watt slug and peak, 1,000 in average, and a 5 watt slug reading forward for the moment. I want to show you something. We're going to start over here on the 5 watt element. We're going to go ahead, we'll key the radio up here. And we're at a 1/2 watt carrier, and the amp is still not engaged. Remember where we are in operate. So there's 1 watt worth of carrier, 1.5 watts of carrier, 2 watts worth of carrier. You got to remember, this is set up for a different era, right? This isn't set up for today. This is set up for the 70s and 80s, right? Where radios come out of the factory and they did 2 watts. 2 whole watts carrier. This thing is designed to catch right at 2 watts. So I want to show you that your minimum dead key to get the amplifier to operate and stay latched is 2 watts. So now your minimum output carrier, as we can see here, 110 watts, 105 watts. This one's showing us 90. This one's showing us 90-ish, 99 watts, and that one's showing us about 102. So okay, let's back this on out a little bit. So we tune this just like we do any other sweep tube amplifier. Bring this and this up until we have our maximum amount of peak power. Bring this in, maximum peak power, and come back and dance back and forth on these. Now I gotta give them credit. They finally gave us a plate meter, but then this is also relative output power. More helpful if they would have put a grid meter in here, but it is what it is. So, hello, 1, 2, okay. Now when I first started playing with this, I could not get it to do over 200 watts. Hence the reason why I had to go in and knock the bias up a little bit. Hesitant to show you how to do that, but we'll show you. Had to pump that bias up a little bit because this thing would not do more than 200 watts. If you get this too far out of tune, the relay just sits there and goes bzzz. It makes a really cool buzzing noise. Sounds like a sex toy. No kidding. I want you to watch how much I move this knob. You know what, here we'll use this knob as an example. That's our set mark right there. Watch. Hello. There's 600. Hello. Okay, this is the most in tune this box is ever going to be. I bet you if we had 100% tubes in this, it would do about 800 watts, but hello. 1 needle's width here equals 200 watts here. Hello. Now we're going to play with the driver. Hello. This thing is incredibly touchy. Incredibly touchy. Whew. Fully functional. Everything works on this. Called and talked with the customer. There's not a whole lot I'm going to charge him for on this. I'm going to charge him a little bit of labor for doing the meter on the front, and that's about it. Appreciate him sending it up and letting us take a quick look at it. 350Z by Palomar Electronics. We're not going to even tease the world and try this on any other band. We're just not. Let's see if it still works. Okay, it does. Please, to my customer, let's look for a hot minute exactly where I've got these knobs. Well, that's not glare. That's actually the mark is right here. Mark is right here. And the other mark is here. Okay, we're in operate. We're on AM mode. The sideband delay does work. We're in high. See these old girls? We can still get the tubes. That's about it. So if we start burning up parts, it's kind of a stretch to find the parts. So, I mean, that's that. It doesn't look too bad on the shop receive radio over there. It doesn't look too bad on the spectrum analyzer, but that's not what anybody's here to see. Right now, with the condition of these tubes, we got ourselves a 600 watt sweep tube box. Like I said, with brand new 100% tubes, you probably pick up another couple hundred watts. Make a cute little driver for somebody. Well, gentlemen, on that note, I'm going to run out of here. I got a busy day. Busy day. I'll have to go adulting stuff. All business-orientated stuff, you know. It's time to go pay the government. That's all I'm going to say. Gentlemen, big thanks to all the Patreons. Shout out to Siglant, MechMan, Excess Power, Bird, Coaxial Dynamics, and a giant thanks to all of you. Appreciate you tuning in, following along. Palomar, 350Z, repaired. I'll see you. Click. Hey, real quick before I disappear, you guys, let's go in here and let's talk about these 3 pots. This one is your relay sensitivity. Do not adjust it. This is your bias sensitivity, the bias voltage. Don't touch it. This one here drives the meter on the front of the amp. Don't touch it. Basically, don't touch any of this. But this is the knob that you have to adjust to increase your bias to get it to put out a little bit more than 200 watts. This one here. This one here, somebody had gone in here and adjusted this all the way to the other direction and it would not key up at all. So if you take this too far, you got to be really careful because you can apply so much positive voltage that you'll end up popping the relay. So you really don't want to adjust this. This here unless you got a really good watt meter and you understand what you're doing, don't leave this alone as well. And this here, all this does is drive the meter up front to show you what the plate amps are doing. So yeah, whole lot of no touch, but I said I'd cover that here real quick. That's the end of that story. All right, guys, have a great day. I'll see you. Click, click.